This coursework has been developed due to the completion of Making Buildings module during Scenario Week. It is focused on measuring and modeling here east with various methods presented throughout the term. At the beginning of the coursework, multiple surveying calculations have been done in order to get a sense of the space and get familiar with the usual methods in which a space is measured. The rest of the coursework has been focused on working in a new software using point clouds to create the auditorium from scratch with the given measurements.
One of the first tasks of the Scenario Week is the leveling run. Through this task, we were able to broaden skills in calculating and quality assuring the work of a surveying team who have conducted a leveling run using the rise and fall method. This was done for the Here East Auditorium in order to compute the height of the 2 floors with a given zero value of the ground level. With the help of the surveying team, several values were already used as input, after which we were able to continue doing the calculations using the rise and fall method, including checks and adjustments. All of the calculations can be found in the Excel that was also submitted. By the end, the heights of the floors have been identified, meaning BM is equal to 0 meters, floor B is 4.0515 meters, and C is 5.4170 meters. Potential difficulties when carrying out this task include equipment difficulties in terms of parallax, collimation, and compensator errors, human error in recording and analyzing the results, and environmental conditions such as noise when recording results.
The next task is a setting out task, the aim of which was to learn how to quality assure the work of surveying team who have designed and set out a stage which has a curved front face. It was carried out on the Here East courtyard outside due to space restrictions inside the auditorium using arbitrary control stations. The stage that has been set out used 2 known control points, Station 1 and Station 2, and consists of 8 points that have been set out. With the given easting and northern coordinates of the points, the quality assurance was carried out by computing distances of 4 sides and diagonals of the stage using coordinates and comparing them to the measured values. Overall, the observed and computed values had small differences between the 2 sets of data. The differences between computed and observed values vary between 1 and 5 centimeters, which is not significant in relation to the scale of the measurements, which is 17 to 29 meters. The potential difficulties during the measurements could have been the apparatus that is used, which is the measuring tape, that might cause some uncertainties as the scale of it is not as precise as it would be for the electronic apparatus. Human error could have been the issue when reading the result, causing the uncertainties. Using hand gestures while directing a team member or not being able to hear the instructions could cause uncertainties in the measurement. The environmental conditions such as rain, wind, or noise could overall affect the results. Changing the prism constant on the total station due to a lot of adjusting could cause error as well. And using a chalk might cause uncertainty while marking a point due to its precision. Next, measured chord distances, mid-chord offsets, and radial distances were compared to one another. The maximum difference between the values is 8 millimeters, which could be the uncertainty of the apparatus used while measuring. Overall, all 3 sets of measurements are very close to one another.
In terms of the thermal imaging task, from the images on the right, in general, the internal wall insulation was effective, as the temperatures on the surfaces of the internal windows and internal walls remained extremely similar to the indoor temperature at the time of the survey, which was about 22 degrees. And from the bottom left image, we could conclude that the electrical sockets appear to be at a temperature significantly higher than the internal wall where they are installed, by about 36%. A replacement socket with better heat insulation could be considered. Finally, from the top left image, we could tell that apart from the bending bit and the openings, the HVAC system remained at a temperature very similar to the indoor temperature, suggesting a pretty decent insulation.
One of the more advanced tasks has been the virtual traverse computation. Through this task, we were able to learn how to calculate and quality assure the work of a surveying team who have designed and installed the control survey running through the Here East building. The equipment used by the surveying team can also be found in the overall report. The control network that was installed by the surveyors is made out of 6 stations, beginning with Station 0. Coordinates in terms of easting and northing for this station were also provided in order to help with the calculation of the other coordinates, alongside opening bearings and clockwise horizontal angles. Through the help of provided virtual booking sheets and Excel calculations, forward bearings of all stations were found as a first step, it leading to the overall computation of the coordinates which can be found on this slide. At the end, a graph has been developed in order for it to be compared to the initial sketch of the control network, then proving to be very similar, the calculations being most likely correct. Potential difficulties when doing this task include human error in calculating forward bearings, error in measuring the bearings in terms of forward and back. The environmental conditions such as rain, wind, or noise could overall affect the results, in this case noise. Broken instruments used for measuring, including parallax, horizontal collimation, line of sight error, vertical collimation, vertical index error, tilting trunnion axis error, compensator index error, and plummet errors.
The next task was a target coordinate task, the aim of which was to learn how to calculate and quality assure the work of surveying team who have placed targets around the Here East Auditorium to help georeference and register laser scan data. The laser scan targets were surveyed with a total station set up on Station 1 and their horizontal angle set to 0 at Station 2. Easting, northing, and height coordinates were computed for 6 targets by averaging horizontal and vertical angles, as well as horizontal and slope distances, which were then used for the calculations. Easting and northing are calculated using the formulas where the initial coordinates of the station are used with the horizontal distance of the target and the horizontal angle. The target height is calculated using the right triangle rule where the height difference is calculated first to then be added to the original station height to compute the target height. The potential surveying difficulties could have been due to the mean value of the angles and the distances were only calculated using 2 readings. Therefore, the bigger sample of data would allow more accurate calculation. The condition in which the measurements are taken, such as multiple people walking around or high levels of noise, could affect the accuracy of the data collected due to distraction of the surveyors. The equipment used could be initially set up with the wrong settings or be faulty, affecting the results, and the collimation error when the line of sight is not truly horizontal could cause uncertainty, but it could be fixed through the 2-peg test.
7 pieces of laser scan data were imported into ReCap and auto-registered to create a merged point cloud model of the Here East lecture hall. Targeting adjustments by manually selecting the positions of the target sheets on the walls was tried but turned out to be decreasing the quality of the model, so the step was undone and the model created by the auto-register was kept. Extra points outside the interested regions were deleted to make the model smaller and cleaner. In order to determine the average point cloud density, 3 1-meter cube regions were extracted and exported as point cloud files. They were then imported into Rhino to be counted, and therefore with an average number determined. The average point spacing was determined by using the equation shown here. It required the 2D average point density to be determined, which was determined using the similar method that was used to determine the average point cloud density, but by extracting 1 meter squared regions instead of 1 meter cubed regions. A BIM model was constructed using Revit. The original approach was to import the point cloud model into Revit to be traced. However, the point cloud model was huge and easy to be misselected, which caused quite a lot of lags and struggles. In order to prevent lags and improve on efficiency, the point cloud model was imported into Rhino first. It was measured and some basic perimeters were traced. Then the perimeters were imported back into Revit for proper modeling. The positions and dimensions of the windows and the doors were measured from the point cloud model and set to the exact figures obtained from the measurements in order to reflect precisely what the laser scan data recorded. A check on the measurements of some of the key elements comparing the actual measurements and the measurements done in the model was carried out and concluded into this table. And turns out that the model was pretty accurate as none of the differences exceeded 4%. And for the element with the largest difference, which is the back right partition wall, the difference could be justified as having the largest uncertainty due to the unclear detail on the joining junction with the adjacent wall. So all in all, it's a pretty accurate method to trace out of a point cloud model based on laser scanning data.
In conclusion, the heights of the 2th floor in the Hears auditorium were computed using the rise and fall method, which has been thoroughly explained. The calculations were all double-checked to make sure that the final result can be used in the further tasks such as modeling the auditorium. For the setting out task, distances measured by the surveyors using the equipment were checked with the calculations to compare the differences and evaluate potential sources of error and uncertainty. There were no major uncertainties or errors found. The thermal insulation results appear pleasing overall, as the temperature of the surfaces of the wall was similar to the indoor temperature. The electrical sockets, however, could be considered to be replaced with a better insulation performance. The forward bearings were calculated in the virtual traverse task for each of the stations due to the given virtual sheets, leading to computing the coordinates. After doing so, these were plotted to compare their positions to the original control network. These were proving to be computed right. In the target coordinate task, the coordinates easting, northing, and height for all 6 coordinates were computed using the data provided to check whether the targets were placed within the auditorium, which they were. During the process of merging the laser scanning data into a single point cloud model, the outer registered model has higher quality than the manually adjusted model, so the outer registered model was kept. There were problems encountered when trying to build the BIM model by tracing the point cloud model due to the size of the point cloud model. But by using the aid from other softwares, an accurate BIM model was constructed in Revit. Thank you.